Hello and welcome everyone. My name is Peter Robinson. This is the Ethereum Engineering Group meetup. Today I have got Austin King on, who is going to talk about standards, cross-chain. We've just been talking about ERC20 or xERC20, but much more as well. Stuff to do with L2 standardization. So before we dive into your slides, do you want to quickly introduce yourself, Austin?
Sure thing. Yeah, and appreciate you having me here today, Peter, and everybody else on the call. So I'm Austin. I'm a co-founder of Omni Network, and I'm CEO of Omni Labs. Specifically, Omni is an interop network purpose-built for the Ethereum L2 ecosystem. And so that is where most of our work focuses. Today, I'm actually not going to talk about Omni too much. If people have questions, I'm happy to tell them specifically about Omni. What I'm actually going to cover much more of, though, is standards for the L2 ecosystem. From our perspective, there should not be any baked-in dependence on any specific interoperability protocol as Ethereum shifts to an L2 landscape. We think that's dangerous to do that. And so we think that there's a way that you can design some of the abstractions so that you don't have to do that. So that's what most of this presentation is about today. Some of this for people who are more experienced in the cross-chain world. I'm sure this will be, some people have heard of some of these standards, but yeah, that's kind of an overall. And then I guess before this, I studied computer science at Harvard, and then I actually did another company that built an interoperability network before this one. So that's a bit of my background.
Wow. All right. Sounds like you're very well qualified for this talk. So
We'll
please
see.
bring
Yeah.
your slides. Let's go.
Cool. Okay. So one sec. Oh, wrong thing. Okay, here we go. And then Peter, just confirming again, uh, this now is like the single slide view, correct?
Yes, we can.
Cool. All right, let's kick it off then. Cool. So today we're going to be talking about open standards for the Ethereum L2 ecosystem. Like I said, I work in the interoperability space at large, and I've been, doing this for a number of years at this point. I originally got involved in 2017, 2018. But today we're actually not going to talk specifically about any specific mechanism for securing interop messages. We're going to talk more about the layer on top of that for how the Ethereum ecosystem should, navigate its relationship with any specific interop protocol. So at large, it's been really exciting seeing the Ethereum ecosystem evolve to become more L2 centric at large. This has caused a problem, though, in terms of degrading the global network effects that were really awesome about Ethereum. It's still fantastic to see the amount of users and liquidity that are in the Ethereum ecosystem today. But as more users and their capital migrate to layer twos, we're kind of losing some of the global network effects. And I think this is especially timely and relevant in comparison to other networks like Solana that are taking a development roadmap that does not risk this. It's a more monolithic architecture. And it's becoming pretty commonplace at this point for people in the Solana ecosystem to criticize the Ethereum ecosystem for having a fragmented user experience that hurts global network effects, makes it harder for developers to reach everybody in the ecosystem, and also just makes it really confusing for end users in the ecosystem. So this we see as something that's existentially important to figure out for the Ethereum ecosystem. The world that we want to build for Ethereum is a world where we can scale horizontally through these rollups in a way that users don't have to think about the complexity of all the infrastructure that's going on under the hood. And in order to do that in a safe way, we believe it's extremely important to establish open standards around some of these like primary primitives. So getting into it, interop historically has been one of the most fraught, to say, categories within the crypto ecosystem. I think it's over half of all the capital that has been hacked in various exploits has come from different interoperability protocols. And so this, I think, is like a great way to communicate the premise of a lot of these arguments. It's that like it is very hard to build systems that are securely passing messages between different smart contract platforms. And this has manifested in a lot of money being lost. Especially one thing that is pretty precarious for the space at large is a lot of this money has been exploited by sanctioned entities, like the Lazarus Group from North Korea. And so not only is this damaging for people who are using these systems so that their money is lost, it also brings a ton of bad attention into the space from, being associated with North Korea and entities like that. So to kind of kick off an example of like how a lot of this is going to be focused on this standard called xERC20, or ERC-7281. In order to set the conceptual foundation for this, I'm just going to walk through an example of a project that previously was running called Nomad. And to be clear, I have a ton of respect for the Nomad team. I know some of them personally. It's just illustrative of what can go wrong in these situations. So Nomad was an interoperability network that was connecting the Ethereum blockchain to the Moonbeam blockchain. It was a pretty cool design, and effectively it was enshrined as like the canonical bridge to the Moonbeam blockchain. So this was really exciting for the Moonbeam ecosystem because it meant that they were able to, simply onboard capital from the Ethereum ecosystem instead of having to bootstrap their own capital pools and like own assets on Moonbeam. So it helped them grow a lot quicker. And so generally what it would look like is you would submit your ETH to the Nomad contract on Ethereum. The Nomad network would pick that up and relay it to the Nomad contract on Moonbeam, which would mint people MAD ETH. MAD was kind of like Nomad. It was the prefix for these different assets. And a lot of these were accepted as like the canonical asset. So MAD ETH, for example, was like canonical ETH over on Moonbeam. And it had this pretty nice user experience where users, anytime they wanted to go back to Ethereum, they would just submit their MAD ETH to the Nomad contract on Moonbeam, and they would get out their ETH on the other side. So pretty seamless for end users. And a lot of this, like here we're talking about a different blockchain, but this applies equally to any L2 or rollup that is on top of the Ethereum ecosystem. So the problem with Nomad was that it broke. There was an exploit that happened, and I think it was about $200 million were lost. And this effectively destroyed the Moonbeam ecosystem at large because they enshrined some specific interoperability network as like the canonical interoperability network. The entire ecosystem was destroyed. This hurt end users, it hurt developers, and it hurt the core platform itself. So a lot of this, like I'm saying, it's important to design the abstractions of how we work with these things so that there can be like independence and sovereignty from interoperability systems. And really, we see this happening at three different layers here. So the first is asset issuers. We do not think that any asset issuer should make their token downstream or like a derivative of an interoperability network. We think that's unnecessarily risky. And we'll cover this, but there's alternatives where people don't have to do that today. Similarly, dApp developers should not build their applications on top of one specific interoperability network. You just don't need to do that, and it brings unnecessary risk because if that interoperability network suffers an exploit, your entire infrastructure is like lost, and that can be extremely damaging to your end users as well. And then rollups as well should not enshrine any canonical interoperability network. The only one that makes sense is like a native bridge to Ethereum, but any external interoperability network should not be enshrined or get too much control over the ecosystem at large, because if that fails, something that's similar to the Moonbeam ecosystem could happen, where effectively the entire ecosystem crumbles. So, kind of walking that through explicitly, asset issuers, if you accept dependence on a specific interoperability network and there's an exploit, literally your entire market cap can just go to zero. For developers, your entire application can crumble. And that not only, risks your business, it also risks your users' funds. And then rollups, like I said, literally the entire ecosystem could collapse if there's too much dependence on any specific interoperability network built into the core ecosystem. So this is all premised on the fact that, we all work in this industry. It's really difficult to build distributed state machines. That is, behind almost all of the work that everybody on this call today does. It's really difficult to do. Interoperability at large, though, is about trying to get a distributed state machine to talk to another distributed state machine. So it's strictly more complex than just getting a secure distributed state machine in itself. And so that's why just kind of like a very simple argument for like, do not bake interoperability risk into the foundations of your asset, your application, or your ecosystem, because you are just taking on more surface area for things to go wrong in that situation. So going back to the Nomad example, it's like, okay, well, if we're thinking about diversifying interoperability networks within an ecosystem, what if we just had a second interoperability network where people could pass data and assets to the Moonbeam ecosystem? So here there's just Daemon, which is just Nomad in reverse. Let's imagine like what would happen if people were doing that. The problem here is that there's two different, you lose canonical asset status if you use multiple interoperability networks. So the upside of this is that you don't have singular risk on one interoperability network, but the downside is it's super confusing for the ecosystem at this point because for users, it's like, what is ETH in this platform? Is it mad ETH or is it damn ETH? And then to developers, it's like, okay, which one should we build with? And that just makes it even more difficult, especially when you're building an application. You don't know which one to choose, and it fragments your liquidity. You can imagine like a DEX pool, for example. If these were trading against USDC, you'd have mad ETH in USDC and damn ETH in USDC. So this is not a great solution. It removes the existential dependence upon one interop network, but it causes other problems. And so we want to be able to prevent liquidity fragmentation as we're designing solutions for this. And yeah, like I just said, the functional problem that happens if you just throw more interoperability networks on there is it gets confusing. There's no canonical asset that comes out the other side as assets are being moved. So let's get into xERC20. xERC20 is an open standard that we're really excited about. And it actually solves this. So if we go back in time, the Moonbeam blockchain might be thriving today if they were using xERC20 for some of these core assets. So what xERC20 does is it effectively removes the dependence upon any single interop network or bridge, whatever you want to refer to that as. And it commoditizes them effectively is what it really does. And so walking through this Moonbeam example, what it would have looked like if we had two interoperability networks is we would have had the xERC20 contract for some asset, let's just call it ABC on Ethereum. And this contract would whitelist these two different interoperability networks so that they would be able to pass data over to the xERC20 contract on the destination smart contract platform to mint that ABC asset. So the really nice thing about this is that it's no longer a wrapped token. I think wrapped tokens have kind of fallen out of favor, but there are other standards that interoperability networks are promoting today, which are effectively just rebrands of wrapped tokens, from my perspective. They're not open standards, despite a lot of the marketing around them. They have specific risk on an individual interoperability network. With xERC20, the really nice thing is that it commoditizes the interop networks and it puts control into the asset issuer's hands. So the asset issuer could say like, okay, cool. As I want to make ABC available over on this Moonbeam blockchain. What I can do is, I can whitelist Nomad. I can also whitelist Daemon. And either of these interop networks will be able to relay assets over there. So this is really nice because now we can diversify across different interoperability networks and we remove that singular dependence. But at the same time, we solve the liquidity fragmentation problem that we were dealing with before. And Peter, you might find this interesting as well. So it's like, okay, we have two different interop networks, but does this actually help with security? What if Nomad got hacked again? Isn't everything going to crumble out the gate if just one of these networks gets hacked or one of these interoperability networks gets hacked? Won't they just mint an infinite amount on the destination chain? You could if you set the limits to infinity, but you don't need to. There is some of this rate limiting baked into the core protocol design. And so here is an example. It's a pretty, like sad chart because this is how it has gone some in the past. This is what it's going to look like if you have no ability to set rate limits on any interop network that you're working with. So in the event that one of these interop networks are compromised, like I just said, they would mint an infinite amount, and then whoever the exploiter would probably just dump that directly onto the market and then just take the token to zero. So what's really important as you're working with these systems, this is honestly something that surprises me that it took Web3 to catch onto after we learned so many of these lessons in Web2. Parameterize your security. Like it is very clear that, as long as you can maintain censorship resistance and permissionlessness at the core interop layer, you should layer on parameterizable security on top of that with things like rate limits. It just makes things way more safer, especially in this more like nascent stage of the industry as things are evolving. So yeah, specifically in the core standard here, you can assign effectively like flow rates or like caps on the flow that can go through each of these different interop networks, which is really nice. We think this is super important, not only in the sense that credit where it's due, xERC20 was built by the Connects team, if anybody is familiar with them. And we think they did a great job not only designing it in a neutral way so that no interop network could become effectively enshrined and like bring that interop risk into these rollup platforms, they also were pretty practical about it. Designing rate limits into the actual standard itself, we think was a super practical perspective here. And sometimes when we see people try to create abstractions or standards that promote kind of like values in the space, like independence and like sovereignty, sometimes they get a little impractical, at least in my history. This is a great example of a team managing to balance these things very well, in my opinion. So they were able to provide asset issuers with a standard through which they can maintain their sovereignty, but it's practical. You can have rate limits at the base layer there in the protocol. One thing that we're working on as well that I think is pretty exciting is, before I get to that, we mostly covered this. You can effectively, let's say that there's like 4 different interop networks here. This gives the asset issuer flexibility and the ability to who they want to onboard. So here, let's imagine that these numbers are the different rate limits. Like let's just make it simple, like a 24-hour capacity of amount of activity that can flow through. And let's imagine they have different degrees of security as well. The least secure one you would obviously want to set a lower bound on, but the second one here that has $1 million, it might cost more for people to relay through this, but it could give people that additional buffer room to really move value through the network without compromising on security. So moving into another layer that we can add on top of this that I think is pretty cool is you can effectively create a multi-sig of interop networks. And so to be clear, some interop networks out there today still operating at scale are effectively multi-sigs. They don't even have crypto economic security, which I think is pretty astounding that we're still doing that in the industry, just given the number of hacks that we've seen. But what I'm actually talking about here is having multiple independent interoperability networks have to authorize a specific transfer. So let's make an example concrete here. If somebody is sending $10,000, probably fine. It's probably fine to just use a single interop network to relay that. But, as an asset issuer, what you can do is you can program in, hey, for my market cap and the amount of like volume and the amount of transfers that are happening any day, it'd be pretty weird if anybody sent over $50,000 in a specific transaction. And so what they can program in is before, if a specific threshold is exceeded, they can program in like, okay, if it's over $50,000, we need 2 of 4 of these whitelisted interop networks to authorize that transaction. And so this further removes the risk that if a bridge is exploited, people won't be able to just automatically mint an infinite amount. Because let's imagine that the 4th interop network here of 400,000 is exploited. What they would do, that gives us $400,000 cap on the damage that can be done. That's still, pretty heavy. And so if you use this multi-confirmation pattern, what you can at least enforce that the exploiter would have to do is they would have to submit a number of repeated transactions to get it through by capping the total amount that they can send in any one transaction to 50,000, or else it'll seek confirmation from another network. And so that gives teams to respond and employ mitigation measures in the meantime. And you can take this further as well. You can program it in any way. So let's say that if it's over 50,000, it looks for 2 of 4. But if it's over 100,000, you can program it arbitrarily so that you would need the effective ACK from 3 of the 4 interop networks that are being used to communicate across these 2 different platforms. So this is kind of one more step on top of the core xERC20 contract here. And we're actually pretty excited about this because you can use it for more than just xERC20. There's an NFT standard that we're working on as well. It takes a lot of the design principles from xERC20, but applies them to NFTs. And you can do a similar thing with those. So at large, that's how we think you should look at the space at large. Interop networks are risky. That is the objective reality. It's really hard to build these things in a secure way. And so we should not be ceding direct control to any interop network as we are building out things in the L2 ecosystem. This applies to rollups themselves, to applications built on rollups, and to asset issuers that are expanding their assets into these different ecosystems. But at the same time, we should not degrade the user experience by fragmenting liquidity all over the place. And we can actually provide a safer, like lower the risk at large through using some of this natively baked in parameterizable security parameters. So the way we look at this at large is we have a really exciting opportunity in the Ethereum ecosystem to, I mean, effectively the way that I view it is horizontally scale Ethereum through rollups. I've been in the space since 2017 and I love the Ethereum ecosystem, but it has really struggled to scale for a long time. Where we're at now is we have the technical roadmap for that to happen. And rollups at large are seeing a significant increase in traction, but there's still a vast majority of the users and capital on layer one Ethereum itself. And we really see this as just like a balancing act. It's like, okay, if we have these more higher performance platforms on top of Ethereum, why are people not just moving over there like in mass today? And it's because there are still disincentives to doing that. A lot of the ways that like assets and app developers can move to layer twos today, it forces them to give up sovereignty. It doesn't need to be that way. With these open standards that we can all collectively begin to use more, we can make it so that the standard abstractions that people use don't require that they give up control to an interop network and bring that interop risk into their core platform. And so if we can remove that, we can think then about, okay, well, if we're removing dependence on these riskier third parties, can we solve the liquidity fragmentation issue? And we can with xERC20. And so this is another thing here that we're just balancing out. So if we can remove the liquidity fragmentation risk, cool, this left side starts to look far more appealing here, where we can take full advantage of the layer two ecosystem at large. We are left with this one on the right here, though, of interop risk. And it's like, hey, can we remove that entirely as we're creating this kind of like seamless L2 ecosystem where all these rollups can communicate and end users don't even really need to think about like what's going on with the infrastructure layer behind the scenes. The reality is, no, we can't remove interop risk. We can mitigate it though with one, more secure interop networks at large, and two, parameterizable security being applied across them, either at the core interop networks themselves or the abstractions that we use on top of them, like xERC20. So this is something that we care a lot about. It's really important to design, while we're talking about standards, it's actually something that's extremely important to design properly because I think everybody in this call can understand it takes a lot of thought to make sure that you don't accidentally push the space in the wrong direction. If this is something that a lot of people are going to be using, here are like some of the risks. Like if in the second bullet point here, if we weren't careful about how we were thinking about growing into that layer two ecosystem, there could become proprietary lock-in. And taking it a little further here, the fourth bullet point, censorship resistance. In my view, there's very little point to spending all these years building an extremely robust and decentralized and censorship resistant layer one Ethereum platform if we just all used an interop network that did not preserve censorship resistance to communicate across L2s. And so there are challenges that we have in this industry right now where we have these extremely strong properties at the Ethereum L1 layer, but as we scale into the layer two, we really are there are shortcuts that are available where we could give up on a lot of those properties, but we don't need to. There are ways that we can just design them properly so that we don't need to compromise on those things. So at large, the way that we view it is sometimes I hear teams talk about some interop protocol being TCP IP or HTTP. We think that's silly at large. The reason TCP, IP, and all these other internet standards took off are because nobody owned them. Nobody was benefiting from them. There was no proprietary lock-in risk. It's really just an incentives problem at large. Everybody was down to use these standards because it wasn't some, AOL proprietary standard. Anybody could. There was no like rent seeking that was happening in the process. So at large, the way that we view interop networks within the crypto industry is not akin to internet protocols. It's more telecom infrastructure. And so we think it's important to categorize this properly so that things like xERC20 can be the equivalent of the TCP IP, where it's like, it's an EIP, it's neutral, it does not privilege any entity, it does not create lock-in, and it preserves the core properties that we're looking for here. Whereas the interop networks themselves, the ones that are passing the data around, those are more akin to telecom infrastructure. They're not the like protocols themselves when we're thinking about the like Web 2 perspective of it. So this is something that I've heard many companies in the space saying for quite some time. And I actually think it's a pretty inaccurate comparison because fundamentally all these networks have business models, whereas TCP/IP does not have a business model. It's just an open, minimal format that everybody agrees to use and actually helps the ecosystem grow collectively faster. Specifically the standard xERC20 that I was talking about a lot in this presentation, that's actually EIP-7281. xERC20 is just kind of a colloquial way of referring to it. There is more work that the Connects team is doing. There are Telegram chats around, I think it's like xERC20 builders. There's a lot of teams that are beginning to use this standard much more, and the tooling around it is becoming much more advanced. So that's pretty exciting to see. One standard that we created as well. And again, credit where it's due to the Connects team. A lot of the foundations for the designs here were laid with the original xERC20 EIP. We're expanding this into NFTs through some of our work at Omni. And then we have not rolled out an EIP for the multi-confirmation pattern yet, but that is another thing that is nice because it can be applied both to fungible tokens and non-fungible tokens. It can kind of be layered into the transfer patterns here. So at large, that's what we care about. We care about solving the fragmentation that is growing in the L2 ecosystem while preserving the core properties of Ethereum. It should be neutral, it should be open, and it should be censorship resistant. And the only real way to do that is through all aligning on these open standards that preserve those properties and don't privilege any specific interop network that would potentially lose that and like not provide them to the fullest degree. So thank you. That's my presentation. I'm happy to talk about Omni if anybody's curious about that, but a lot of this presentation I wanted to be fully focused on how we're looking at the growing L2 ecosystem and how we think using open standards at large not only could accelerate the growth of the L2 ecosystem, but help us migrate to the L2 ecosystem in a way that is safer and aligns more deeply with the core values of Ethereum.
So thank you for your talk. That was really interesting. I know I put some questions in chat, so why don't we have a look at the questions in chat, go through them, and then you can tell us a bit about Omni. Does that sound like a plan?
Yeah, sounds good. Sorry, I just saw these questions. Sorry if you
Well,
want me to answer
that's
them.
okay.
Yeah.
Yeah.
Cool. Just saying it out loud for the recording here. So who gets to configure the rate limits? The fundamentally important thing here is the person who created the thing. Nobody should be setting standards. You can outsource it if you like don't want to think about these things. But who gets to configure the rate limits for assets? The asset issuer. Who gets to configure rate limits for if it's a dApp? The dApp developer. That's kind of what I mean with like sovereignty should remain in the hands of the people who built the things. It should not be just like arbitrarily decided by some third party. Some teams probably don't want to think as much about like risk management and they like will be happy to take recommendations from some third parties. But ultimately, if there is a party who has the like cryptographic ability to set these rate limits, it should be the people who built it.
Okay. So say I've got a chain where all the rate limits are set to $100,000 an hour or something, and
Mhm.
someone has a meme coin that they bridge across and they say that one's infinite, and then a whole heap of the meme coin gets traded on my blockchain.
Hmm.
or my organization or consortia's blockchain, then it's sort of it feels like a bit of a hole, like a path that a lot of money could disappear out of. But
Hmm.
yeah. I
Yeah,
guess,
I mean, to
yeah, sorry, go ahead.
yeah, just to make sure I understand the proposition properly, it's that if you set the rate limit to infinity and a bunch of people use it, right?
Yeah. Yeah. So,
Yeah,
so,
yeah, for
so you could have a roll up, say that, you've been
mhm,
working on and you've got all the like USDC, or anyway, common tokens, you've got them all set. Um,
mhm,
and then someone bridges in a token themselves, but then doesn't set any rate limits for you.
mhm,
So then, whereas you might have some tokens that are rate limited, you might have other
mhm,
ones that the token owner said, we're not setting a rate limit, which, yeah, because then the question is, whose problem is it? Is it the token's problem,
mhm.
or is it
Yeah,
the blockchain or rollups problem if there's a hack? Um,
yeah.
yeah,
It's actually a very good question. I understand more what you're getting at now. The candid answer is it's both of their problems. Like as a platform itself, this is the trade-off you get with permissionless innovation. People are going to go do sometimes some crazy things. Sometimes people are going to go deploy applications that might be a little risky from the financial perspective and like lever up too much. But as like a smart contract platform, at least the ones that I care about contributing to, like that's kind of the trade-off. If you're building an open platform for anybody to build on, they're they might do some wild things sometimes. So it is something like if somehow this this degenerate meme coin picked up a ton of traction in the ecosystem, it's possible that it gets too deeply embedded in the DeFi ecosystem and it has follow-on effects if there is an exploit with it. But primarily, the concern would definitely be in the creators of the asset themselves. Like if they are establishing infrastructure to take their asset across different platforms and they're doing that in a risky way, they obviously are the most at risk. There might be some knock-on effects to the roll-up if it somehow if somehow an asset like this gets deeply ingrained in the DeFi ecosystem. But that's just kind of like the situation that you deal with when you have like an open organic developer platform.
for sure. So I can see David's got his hand up. So David, please fire away.
Thank you, Austin and Peter. So, Austin, you bring up a really good point about standards, and as a bit of background, I've done a lot of standards over the last couple of decades, and I think
Hmm.
the reason some standards really work and that other standards really fail typically does come down to this issue of how people are incentivized to deal with them, right?
Hmm.
So where standards fail, it's typically because somebody proposes a standard because it's a good technical idea without taking into account the sociology and the economic incentives of the individual players who you're asking to adopt them. And so I think you're spot on um, there. I think I could probably add some things to your analysis, but it was an excellent point. That's just a comment. My question is, so far in the bridge exploits, especially the big ones, what we've seen is that the hackers have executed an exploit as rapidly as possible and moved the funds into different wallets around different addresses to other chains as rapidly as
Hmm.
possible.
Yep.
Now, in some sense, that's a naive attack type, right? So if you have an attack that's worth billions, some of these people have just gone, "Hey, scream it from the rooftop. We're going to take out all the money right now, and we're going to move it to other chains right now." And
Yeah,
so, therefore, we get into this conversation about rate limits, which, as you pointed out, even if you set reasonable rate limits, it can still hurt if you get hacked.
for sure.
So I think my fear in this regard is we're going to start seeing more nuanced attacks where they're taking out smaller quantities over longer periods of time. And then, of course, rate limits aren't the solution. I'm wondering if you've given any thought to that. Thank you.
Yep. Yeah, it's a great question. I appreciate it. I very much my perspective here is I'm curious for your response. It's a very practical one where it's like low-hanging fruit. Uh, if we can get the world to a place where people are incrementally taking out money, it is nice because, that's all visible on chain. And so there's a higher likelihood that that exploit would be discovered, and the damage would be mitigated. Um, I think at minimum, we should move from a world where in a single transaction, an entire ecosystem collapses. That is kind of my perspective here, where it's just like a step in the right direction. Do these standards solve risk of working in a cross-platform manner entirely? Absolutely not. I think we're a number of years away from that. Maybe never, if we're being like frank. But in my perspective, the reality where it's like, people are incrementally executing a drain and it takes an hour as opposed to a single transaction, that is already a huge step up because it gives teams the ability to respond and possibly, in the first 30 minutes there, they could cut off the flow to any of these platforms. So that's mostly how we look at it. It's just like we have not handled this very well as an industry so far. And so there's some like very low hanging fruit in regards to how we can substantially improve the problems that are out there today. And ideally get it to a world where the best way to exploit these things is incrementally over a long period of time instead of atomically to the tune of like $1 billion.
Yeah, I think that's right. The one caveat that I might add to it would be that there are a lot of rollups, side chains, L2s of one form or another that don't really post that much on mainnet. What they're doing is they're pinning some state, and that has in many cases limited utility for forensics. So it's what we might see if your logical next step plays out. We might see a real change in the way those L2s need to play the game in relation to mainnet. They may need to provide more forensic data to be posted. Otherwise, they could get drained. They could go out of business, slowly versus quickly. And I'm not sure we'd actually see any benefit from it. Yeah. You could still take down an ecosystem doing that. All you have to do is be under the profit margin of operability, right?
Yeah. I think you bring up a great point where this is kind of there is so much room for improvement in the Ethereum ecosystem today. And so, what you're talking about here, put in almost not even put in a satirical form. Like most rollups today are running a single centralized sequencer. And so you could imagine a reality where the sequencer just stops withholding state updates of what is going on. And then, by the time they inform anybody, it's drained. And so what you're alluding to here, I think is another huge problem with the way the Ethereum ecosystem is evolving, where there is a complete centralization at the layer 2 layer right now in almost all cases. I'm actually not aware of a single rollup that is running a decentralized sequencer right now. So in the way that I look at this is like that's another problem to be knocked out. We're actually releasing the way that we built Omni. We were effectively inspired by Ethereum's double execution, or Ethereum, kind of runs two clients in parallel. It has the execution client and the consensus client. We built Omni in a very similar way, and we're open sourcing that tomorrow. And so not only can you use that to build new chains like Omni, you can use it to decentralize sequencers of rollups. And so to answer your question directly, like, yes, that is totally possible. And it's something that like people might do eventually. There are other types of attack vectors that are opened up when you can withhold information like that. So our perspective here is like layer 2, it should not be as decentralized as layer 1 because that just kind of like you lose the performance benefits. But there should be some degree of decentralization here, or else you like there are exploits like that are just kind of like super low hanging fruit to execute if you found an exploit.
You've given a law of computer science, right? Which is that you can solve any problem with another level of abstraction.
Yeah.
The problem is that normally causes other problems, right? Which you then solve with another level of abstraction. I mean, that's the business we're in. And decentralized sequences, we've had, I think, 2 talks in this group recently on decentralized sequences and their economic benefits. And one of the things that came out of it that really stood out for me was that when you apply those levels of abstraction, you do change the economics of the viability of the L2.
Totally.
Right, because you're adding operational costs, you're adding time delays, you're adding, maybe even people time. So I am both with you that we need to mature these things, and yet I'm still trying to wrap my head around what the unintended consequences of those decisions are going to be.
Yeah, I think that's totally fair. And I love describing abstractions on top of abstractions as our entire industry. That's crypto for you, for sure. Yeah, all very fair points.
Yeah, well, thank you anyway. Appreciate it. Great talk.
Yeah, appreciate the questions.
And so immutable, how we're dealing with the problem that David posed was monitoring and data analytics, which I assume most blockchains are. They've got bridges and they're doing big time understanding where the money's flowing. I mean, which is essentially what you're saying. Anyway, Jake, you've got your hand up and you've had your hand up for a long time, so you must have a tired hand. So please ask your question.
Thanks, Peter, and thanks again for organising this. Always fantastic. So thanks for having us. And also, really great presentation, really clear. Just a couple of things sort of worth mentioning. So we're supporting Omni in the eigenlayer ecosystem as an operator, and we work with Chainlink, supporting CCIP and thinking about these things, low latency feeds for oracles. And there is obviously a really important role that needs to be played for having liquidity around the token to really power DeFi. That's a huge issue. Where is the liquidity sitting? Which L2 is it sitting on? The interoperability, it's a huge problem. But my question is more around the role and function that eigenlayer plays for Omni, and where that can introduce some of the benefits. That I think people are largely confused about restaking and sort of getting lost in stake drops or airdrops as opposed to the actual technology there. Can you maybe just give us a little bit of an explanation of where Omni sits in eigenlayer and where the xERC20 can play a role to help liquidity in that ecosystem?
Yep. Yeah. Appreciate the question. So I will give a brief overview of Omni to answer this question. So Omni was built because originally we built a DeFi protocol on Ethereum layer 1, and we weren't satisfied with any of the security properties offered by any interop protocols that were on the market. So what we set out to build was an interop solution that was as close to Ethereum native as possible. And what that ended up looking like was the best way to achieve that was to take the crypto economic security budget of Ethereum itself and apply it to an independent network that is attesting to state updates so that we could relay these messages. So what Omni does is it's an independent network of nodes that are all secured by restaked Ethereum. What they're doing is they are attesting to state updates across these different rollup networks so that they can pass messages securely across them. We started working on this about 18 months ago, maybe like 20 months ago at this point. And it was very interesting because, it's been a while to see the evolution of all this. We met the Eigenlayer team originally at Stanford Blockchain Conference, and it was kind of a zany idea back then, but it clicked with us. We're definitely one of the teams that have been working with them the longest, if not the team that has been working with them the longest. Because it was very esoteric at that point in time, but now, there's $15 billion in these contracts. And it is, one of the most hyped projects in the entire ecosystem, crypto industry. And so it has been exciting to watch it play out. We're at a point now where there's about $4 billion of restaked ETH that is in Omni's restaking contracts. And so it's exciting to see like this idea that started, about like 2 years ago now, actually playing out at scale. There's going to be literally billions of dollars of crypto economic security that is securing all the state updates that are relayed through Omni. And something like that wouldn't be possible without restaked ETH. So that's overall, I'm happy to answer anything more specific in regards to the like restaking or eigenlayer dynamic there, but that's an overall view of like what is Omni and like how, like what is the security model that we utilize for it.
No, that's excellent. And then just maybe just to touch on that further, in terms of like slashing rules and how that all plays out and the role and function of the eigen token or the B eigen token, have you sort of a clear view in terms of how you see that playing the role in Omni? Is that clear for your team at this point?
Yeah. So I mean, from our perspective, it's a 40-page plus white paper, so maybe there's more reading to be done here. But from my understanding, it's that the eigen token is there for judging things that are not objective. Omni was very purposefully built to judge things that are objective. And so what we can do is we can just look at the rollup state itself. And so this allows us to rely on the restaked ETH. Maybe there is something we can do with eigen, but at least from my like eigen the token, but my initial impression is that it's actually more applicable to networks that have like non-provable slashing conditions, whereas that is not the case with Omni.
Great answer. Thank you so much.
Yeah, thanks.
Okay. So Faye has a question, and I'll read it out. I'm trying to visualize how xERC20 standard can solve the liquidity fragmentation problem. Say all the rollups dApps had adopted the standard, would I be able to trade tokens like all the liquidity on different rollups is in local to the rollup I am on? I cannot imagine we can trade on the liquidity of all rollups in a single transaction. Yeah, I can see the ambiguation here. Anyway,
Yeah.
over to you, Austin.
Cool. All right. So to try to frame how I'm hearing this in my brain, will xERC20 allow us to make swaps in all liquidity pools that are available everywhere atomically and effectively aggregate all liquidity so that anytime we're swapping, we can swap against all the liquidity pools instead of just the one in the local rollup environment that we're in? The answer is no. That takes technologies that I think maybe the most interesting at this point is a sequencing marketplace like Espresso Systems is building. But what you need to do in order to execute global, like aggregating atomic transactions like that, you actually need to enforce transaction inclusion across a number of different smart contract platforms. So xERC20 exists at a different layer than that because what you need to do is get sequencing rights over the all the independent sequencers that you would be aggregating liquidity across. So that's a level deeper than what xERC20 applies to. xERC20 is more like, all right, cool. There's no liquidity fragmentation within a single smart contract platform. There is still going to be some tokens on one rollup and some tokens on another rollup, and there might be liquidity pools for that token in these different rollups, but there's not going to be version of token 1 and version of token 2 within the same rollup platform. So that's kind of the distinction there.
Yeah, that makes sense.
Faith,
Yeah.
I was just going to say, Faith, if that didn't help. Okay, cool. Yeah.
Yeah. I think, it's all good.
There's a nice, sorry, real quick, Peter. With xERC20, it's nice, simple. You can deploy tokens that way. In order to get global swaps that aggregate all liquidity, that's a whole other animal that is not going to be like a simple open standard like xERC20.
Yeah, too right. It's a complicated problem. But anyway, I think it's one that'll be solvable in with things like AgLayer is one thought. Why don't you tell us a little bit about Omni? And then, yeah, why don't we do that?
Cool. And then to answer the only other question I see in the chat right now, if I'm missing one, feel free to just bump it again here. But Babu, you asked, what is the business model for the interop system? The business model for any interop system is, well, I mean, the fundamental metric that they primarily care about is going to be drive transaction flow, drive the number of messages that are being passed through this network and relayed. There's different things you can do on top of that. So Omni, for example, only cares about messages that are getting passed. But that's because it is an interop network. I make this distinction. I think a lot of people don't see it this nuanced. Omni is an interop network. It is not a bridge. Bridges tend to take a spread on the value that is extracted or that is relayed. And they are specifically built for relaying value. Often you can build bridges on top of interop networks, but an interop network is the more general platform through a bridge is an application of what you can do with an interop network. So with Omni, for example, what we like the numbers we care about are driving the number of aggregate messages that are relayed across rollups that are secured through Omni. And so the business model there is it takes a spread on gas, not on value that is relayed through the network. But that's Omni's model. Do you have anything else that you want to ask there? Otherwise, I can skim through a deck on Omni quick. Cool. All right. Well, thank you for the question. So this I'll keep shorter than the first one, but I will give you all an overview in regards to what Omni is and why we built this thing. All right. Can you see this again, Peter?
Yes. Yep.
All right, cool. So what is Omni? It's effectively the first blockchain that is purpose-built to complement Ethereum L1. And so a lot of times, historically, L1s have been, or blockchains have been built to compete with Ethereum in some dimension. Like they have tried to compromise in some dimension or another, maybe increase throughput, but lower security. Omni is a blockchain, but it's actually not designed to, it's not like Avalanche, for example. It's purpose built to make the Ethereum ecosystem better and work with the existing infrastructure stack. Like I've said a decent amount over this, it's specifically built to let rollups communicate with one another. And kind of coincidentally, just the best architecture for achieving that was through being a chain in itself. But conceptually, that's how you should think about Omni. So, this is actually this chart. Yeah, this is from February 27th. I think it's steadily over a scaling factor of 10x now. So this is super exciting. Ethereum is moving to rollups finally. Not finally, it's really hard to make these technologies. And like Peter, props on all the good work you and the rest of the rollup teams are doing. But we're now seeing it at scale, in order of magnitude more scale than is happening on ETH-L1. It's extremely important to think about like how the rollup ecosystem is evolving because it's here. We've tried to scale through a number of different forms here. Actually, my first company was built around payment channels. What we did was we linked together the Lightning Network with payment channel implementations that were on Ethereum. The main constraint here is that these were payments, though. And we've had a couple iterations since then. We're now at rollups where they're Turing complete. We can run a full EVM. We can actually even run just arbitrary virtual machines in these environments. So we very much see rollups as the like end game of scaling on Ethereum, at least in terms of the structural format there. But like I've said over this call, this is causing issues of fragmentation everywhere, both for users and for developers. And so, yeah, the way that we approach this problem when we were trying to solve it for ourselves is like, what would the ideal interoperability solution for Ethereum look like? And so there were a couple things here. One, it needs to derive security from Ethereum L1. It needs to be as close to Ethereum native as possible. So we achieve this with restaking. Two, it needs to be extremely performant. Our view of the world is we need to get the infrastructure performant enough so that users don't think about rollups. And users should just like use applications and websites it should not matter to them what rollups are being used behind the scenes. That's too in the weeds. Like, you don't think about like what data center is hosting your website when you go to a website. You just use the website. And if you're going to be providing that user experience where people can hop around these rollups quickly like that, you need to have an extremely low latency interop network that allows these rollups to talk. And then extensible, it needs to work with any virtual machine that rollups will run. So that's high level of the design goals we have for Omni. From our perspective, the way that this has evolved over time is the initial interop networks that we had largely were trusted verifier sets. I saw one comment about Wormhole. This is the current architecture of how Wormhole secures messages. It's trusted parties, they're called guardians, but there's not crypto economic security layered on top of it. From our perspective, xERC innovated on this. They layered crypto economic security on top of it. So at minimum, you're not just trusting some company to behave in their best interest or behave in your best interest. And so there's actual like crypto economic risk for those validators who are, or whoever is attesting to these messages as they are participating in the network. What we wanted to do was take this further. The limit that we saw with this was that xERC is just secured with AXL. I think the market cap is around $1 billion right now. And so that means like at max, the crypto economic security that can be provided there is the entire market cap of the AXL token, which is like around $1 billion. For context now, you know, this deck is a bit older, but it communicates the opportunity here pretty clearly. Omni is in its very early stages, and there's over $4 billion of ETH delegated to be securing messages passed through Omni. So we decided to use restaking for two primary reasons. One, the scale. We needed a solution that could scale its security budget to Ethereum grade levels. And two, volatility. It's risky if the security budget of a network, like let's imagine something went wrong with Omni and it was only secured with Omni, the token. That could be a recursive feedback loop that could degrade your security properties at the time that you need it most. And so having something that is independent, like ETH securing the network, is extremely nice. So yeah, at large, kind of like I said, we met the Eigenlayer team a while ago, and this kind of just clicked for us. Another thing here is we were really between ZK and crypto economic when we were thinking about this originally, but ZK was just extremely slow and expensive. It'll get to a point where ZK will be practical to be used as an interop, as a mechanism to secure interop messages. But currently, you know, it takes like, I think state of the art is about 3.5 minutes to generate a single one of these verifications, whereas Omni can do this consistently in under a second with extremely high degrees of crypto economic security. So that was kind of the fork in the road is, do we build it with crypto economic security or ZK security? And we were really excited about discovering restaking because crypto economic security effectively did not hit our security threshold that we were looking for previously. But if we used ETH as the asset to secure it, that really unlocked the opportunity for the more performant and inexpensive solution of crypto economic security to be used. So yeah, and from kind of a more formalized perspective here, we were trying to do the best of taking native security and pairing it with an externally verified system. So that's why it is an independent chain. It's because it's independent nodes actually doing this. They all just like are secured with ETH, the asset. So from a high level architectural perspective, this is kind of what it looks like. You have the validators in the Omni network registering in on Ethereum L1, and then the layer twos. Omni is observing all the state updates from what we call portal contracts on these different rollups, and coming to effectively like a global consensus on these portal contracts, which allows them to communicate with one another. Performance, like I said, actually, this is something that I didn't touch on as much, and relevant to a prior comment on decentralized sequencers. One thing that we're really excited about with this architecture is we built a new chain architecture that allows us to do this all and run Comet BFT so we can consistently finalize in under a second. And this is in the for decentralized sequencers, this is really exciting because a lot of what has held back sequencers from decentralizing previously is the fact that all the users have gotten used to this like near instant confirmation user experience. And so if we're doing something with like 3 to 5 second block times, we would actually be degrading the user experience as we start to decentralize our sequencers. And honestly, people probably are just not going to do that. And so what we're really excited about with this framework that we're calling Octane, that we're releasing tomorrow, is that it can consistently finalize in under a second. And so the difference in the user experience won't really be noticeable, even as people are decentralizing their sequencers. Here it's just an overall flow in regards to what it looks like as messages are passed. It's like a user makes a transaction, and some developer, would receive that or that some developer smart contract would receive that transaction. And let's just say that like I'll walk through a super simple example here. Let's imagine it's a to-do list. Rollup A, a user is on Rollup A and wants to add something to their list that is on Rollup B. They would talk to the smart contract, which would call the portal contract. Omni, the network itself. Halo is the consensus client that we're running. What we do is we observe those state updates, we package it up as an X message into an X block, run a consensus process around it. So that's like the 4 bil of restaked ETH, which is attesting to the validity of that. And then it outputs a block, which a relayer, which is a permissionless role, will relay to Rollup B. I'm happy to go deeper in the weeds there, but that's kind of high level, the flow. Yeah, and we purpose built Omni so that it could work with new Rollup VMs. We saw this when we started working on this about 18 months, 2 years ago, as a really exciting opportunity. I think so far what we've seen is most teams have tried to focus on matching the developer experience on Ethereum L1 with EVM equivalents. But one huge opportunity we see here, and I think this is getting more attention recently, is alternative VMs. I think there's a really cool opportunity we have to bring more Web2 developers into the industry at large and work with, just other languages that they're more familiar with. So yeah, one thing you can do that's really nice with Omni is you can build applications that look natively global, like they're available across all these different rollups. That's high level the developer experience that we're shooting for at large. I can go deeper into that, or we can keep this more technical. But high level, that is Omni at large. Happy to answer any questions. It looks like there's one message in chat here. Got it, David. David, to your comment. 100% credit where it's due. Axelar definitely pushed the frontier as they implemented capital that is slashable in the event of malfeasance or like malicious behavior from a node operator. Ton of credit where it's due. So that's Omni.
So the peer-to-peer network that you're using with the Comet BFT, is that like essentially the consensuses or rather Ethereum's consensus layer, but switching out Ethereum POS for Comet BFT, or is that your own peer-to-peer communication tech?
Thank you, Jake. That's nice of you to say. Peter, to answer your question. So the really cool thing about the framework that we built is it effectively it's the first implementation of the engine API that is not talking to the beacon chain. And so it's the first time that a little bit of history for everybody. Historically, there have been multiple attempts to build an EVM that runs Comet BFT. This has not, it's, credit where it's due. Good work's been done. It's a really difficult engineering challenge. But from our experience, we actually ran one of these. We ran one of these called Ethermint, and it really struggled under load. We actually, we onboarded like 400,000 users in our last testnet. And when you push it at scale, like block times start to hit like 5 seconds, your RPC latency starts to turn to like nearly like a second plus. The mempool starts to tip over. And it's because what they did was they had the Cosmos SDK and Comet BFT, and they built an EVM on top of it. our architecture, after running our second testnet with this and just seeing that it wasn't going to hit the performance properties that we wanted, we used the engine API from Ethereum alongside ABCI 2.0 from the Cosmos ecosystem. Whoa, interesting. Usually that doesn't happen with me, but anyway. Anyway, that's how we let them talk to each other. So the cool thing here, Peter, to answer your question directly, is it allows us to use frontier Ethereum execution clients like Reth, even like if you all are following the development of the like Rust-based Ethereum client, alongside these more performant consensus algorithms. So like today we are using Comet BFT, but there's also really cool ones like Narwhal, Bullshark that are out there that I think present like a really exciting opportunity for a bit longer term things for teams to explore. So it's kind of it's a clean abstraction sense, like we can get the best EVM execution clients and we can also get the best consensus algos that are out there.
Yes, sounds really interesting. Yeah. Yeah. Okay. That's really interesting. So thank you.
Mm-hmm.
Are there any other questions for Austin today? Okay. All right. Well, in that case, thank you, Austin, for a great talk. Very interesting. For those people who are watching this on YouTube, there is a meetup. Just look Ethereum Engineering Group meetup and you'll find it. People who are here right now, this is going to be on YouTube. The slides will be in the description on YouTube. So, and I hope to put that up probably tomorrow, but sometime in the next 24 hours. So, yeah, so thank you again, Austin. That was awesome.
Thank you, Peter. And thank you to everybody else. Jake, thank you for the questions. David, you as well. Shout out to you all for running this, especially for so long. I had no idea that this has been going on since like 2018, 2017. So I respect it. And yeah, I'm hoping to become a consistent member here.
Yeah, for sure. Hopefully you'll find time, or even if you just watch the YouTube videos every now and again.
Mm-hmm.
Yeah. All right. Talk to you all later. Bye-bye.
All right. Thank you, everybody.
Cheers.